All right, let's get right into it. Welcome to this explainer. We've had a lot of requests to create an English language video specifically for offshore operations, and today we're zeroing in on something absolutely crucial. We're going to unpack exactly why a meticulously crafted lift plan is your ultimate lifeline out there in heavy industry. We'll be looking directly at standard industry documents, specifically the MPF, QSSE.017, and OFMART 04 forms, to figure out how they actually keep us safe on the job.
Look, it's a completely serious question. What actually stands between a totally routine, everyday lift and an absolute catastrophe? If you just quickly glance at the paperwork, you're probably just seeing endless pages of checkboxes, blank fields, and signature lines. But to answer this question, we have to look past the dense bureaucracy. We need to transform these forms into what they truly are, a dynamic, living blueprint for your crew's survival and success.
To make sense of it all, we're breaking the anatomy of an offshore lift down into 4 key pillars today. Number 1, hardware and load. Number 2, environmental hazards. Number 3, the human element. And finally, number 4, step-by-step execution.
Okay, let's dive into part 1, hardware and load, the physics of the lift. This is all about respecting your crane's strict limitations and the intense physical reality of the object you're trying to move.
Now, here's where things get really interesting because there is a massive contrast between onshore and offshore lifting. Working on land, sure, you generally just need to know the static weight of your load. But offshore, no way. We can't just rely on the calculated static hook load in air. We have to rigorously account for the max calculated dynamic hook load and the submerged weight. Think about it. When you're lifting something off the ocean floor, water resistance and extreme seabed suction can literally double the weight of your load in a split second. The environment is actively changing your physics in real time.
And that wild unpredictability brilliantly illustrates why nailing down the center of gravity, or COG, is completely non-negotiable. The lift plan forces you to declare if the COG is obvious, if it's an estimate, or if it's been hard verified through engineering drawings. Because getting this wrong, it means a violent, uncontrolled load shift the very second that asset leaves the deck or breaks the surface of the water.
Beyond just the load, the plan also sets a hard boundary on the crane's absolute limits. You've got to document the maximum available hook height and the maximum radius. This ensures the crane's configuration and its safe working load, the SWL, are never, ever compromised. It's essentially a mathematical guarantee that your gear can handle the crazy physics you've just mapped out. Moving right along to Section 2, Environmental Hazards, the Defensive Shield. Physics is only half the battle, so let's see how the plan builds an active defense against the wild offshore environment. If you've ever stared at these raw forms, you know they hit you with this massive, dense block of safety measures. It's honestly a bit overwhelming, but breaking it down into distinct battlefronts really helps. First, you've got environmental factors, things like sudden weather shifts, rising wind speeds, and unpredictable wave heights. Then you've got positional risks. This includes the incredibly high stakes of blind lifting, where the operator is basically flying blind. And finally, equipment variables, like those sudden buoyancy shifts we just talked about. You have to anticipate every single one of these before you even think about rigging up. For remember, the environment isn't just the weather. It's also about who and what is operating around you. We have to actively map out any proximity hazards. The forms demand that we check for conflicting operations. Are helicopters flying in today? Are we dropping loads near fragile subsea assets? And most crucially, are there diving operations happening? Because lifting heavy equipment anywhere near divers is an incredible risk that demands absolute, perfect synchronization.
All right, on to Section 3, the human element, communication and survival. Because let's face it, the strongest cranes and the most perfect physics calculations are totally useless if human coordination fails.
This is where the plan lays out the absolute non-negotiables for your lift team. Communication is literally everything out there. You have to establish a primary comms method, usually VHF radio, but you also must lock in a secondary backup. If the radios die, you need confirmed visual hand signals ready to go. The plan also forces a check that everyone has the correct PPE and harnesses on, and, this is a big one, that a fast, efficient means of rescue is completely prepared before anyone even touches a sling. I want to highlight this direct critical mandate. All non-essential personnel excluded from the area. Barriers to be used as appropriate. The lift plan dictates strict, no-nonsense exclusion zones. It enforces physical barriers to keep anyone who isn't directly involved in the lift safely out of the line of fire. Simply put, if you aren't on the lift team, it should be physically impossible for you to accidentally wander into that hazard zone. Which brings us to Section 4, Step-by-Step Execution, the Method Statement. This is where we take all of those isolated hazard checks and weight calculations and forge them into a cohesive action plan. Those blank, numbered lines on the form, we boil those down into a relentless chronological sequence. Step 1, execute your pre-use checks and run a thorough toolbox talk with the crew. Step 2, attach the load and formally confirm your comms are working. Step 3, actually execute the lift, keeping a very close eye on those dynamic factors. And finally, Step 4, achieve a totally secure laydown, safely detach, and lock the load down. Down at the very bottom of the paperwork, you'll find the signature blocks. Lift plan completed by competent person, approved by lift supervisor. These aren't just autographs, they are the ultimate sign-off. When the competent person and the lift supervisor sign that page, they are putting their professional reputations on the line. They're taking ultimate responsibility for the lives of their crew and the safety of the massive assets involved. It's a huge commitment.
I want to leave you with this final thought. Because a lift isn't actually over when the load clunks down safely onto the deck. It's only over when the debrief happens. Did everything go exactly as we drew it up? Or do we need to mandate some serious changes for next time? Treating every single lift as a learning opportunity is how we guarantee the next one is just as safe or even safer. So ask yourself, the next time you're reviewing or signing off on one of these plans, are you just blindly checking boxes, or are you actively engineering your team's survival? Thanks for joining me on this explainer, everyone. Stay safe out there.